Good afternoon. I am Dr. Anita Thomas, Head of the Department of Mathematics, Bishop Abraham Memorial College, Pathanamthitta District, Kerala State. Warm welcome to the workshop on short magical tricks in mathematics conducted by our department. This workshop is being conducted to understand how Vedic mathematics is relevant even in the 21st century. We also aim to motivate students of all streams to love and learn mathematics without fear. Our resource person, Sri Srikant S., is my student and a renowned trainer. Now he is working as the course director, Talent Academy, Trivandrum. He has unlocked the potential of Vedic mathematics even to crack examinations like UGC NET and civil services. So you are all in good hands for these 2 sessions. Now I request our principal, Dr. Viju T. George, to deliver his message. Thank you.
Good afternoon all. Respected Head of the Department of Mathematics, Dr. Anita Thomas, Mrs. T.G. Matthew, dear resource person of this online workshop, Mr. Srigandas, teachers, students and other participants of this workshop. On the outset, I would like to congratulate Head of the Department of Mathematics, Dr. Anita Thomas, and teacher Mrs. T.T. Matthew for organizing this 2 days online workshop on Vedic Mathematics. It is a relevant and a highly useful subject for all students seeking a job in government departments, banks and other institutions. I expect, since this workshop is organized as an interactive mode, this program will generate insights in Vedic mathematics and to learn shortcut techniques in mathematics, which is an indispensable part in all competitive examinations. On behalf of the B.A.M. College community, I welcome Mr. Srigandas to lead this program. I express my best wishes to all participants who utilize their valuable time in this pandemic period for acquisition of knowledge. Thank you very much.
Respected teachers and students, please remember all the following instructions throughout this program. Please mute your audio and turn off your video during each session. Avoid posts like hi, hello, good afternoon, good evening, etc. in the chat box. You can post questions and doubts in the respective chat window of YouTube and Teams. There will be an interactive session at the end. In that session, we discuss the questions posted in the chat box and the participants in Teams can raise your hands for interaction. We select a best participant from this workshop. For that, we will post a form in the chat box after each session and you should submit the form within 20 minutes. A feedback form will be posted in the chat window and the e-certificate will be issued only for those who attend the program and send the feedback. Thank you for your support and we expect your active participation. Now we have our resource person with us. I invite Srikant sir to engage the session.
I would like to thank the B.A.M. College management and the principal Dr. Viju T. George sir, and a special thanks to our beloved Anita teacher, HOD Mathematics, and all other teachers, staffs and students who put their efforts for conducting this session. Even though in such a challenging time, conducting this session is really appreciable. And also I would like to thank my organization Talent Academy, where I am working currently as the course director, for providing infrastructural and moral support for conducting this session. And when it comes to B.A.M college, for me, lots of sheet memories are there about my college life in B.A.M college. I was a student of the 2002-5 BSc Mathematics batch there. I still remember when I came to the college for the first time, I was a very timid and shy kind of personality. But by the time I graduated from the college, I was capable of standing in front of a crowd and talk about any matters which I know. So this confidence which I gained from my college life is my strength in facing any obstacle throughout my career so far. So dear all, to coming our today's session, being a proud alumni of the B.A.M college, I am more than happy to conduct this session on magical tricks in mathematics. So our today's session, we will discussing some of the core areas from there. The questions are coming for competitive exams like UPSC, SSC, bank, state PNC and other similar exams. So in this particular session, I will be discussing the shortcut techniques, because as you know, this competitive examination approach will be something different from that of the academic studies. Simply if we can for a simple comparison we can say that for example if we compare with cricket, there will be a difference of something like a test match and a 2020 match. Our academics is kind of a test match, because from our first standard or even from our LKG, UKG time to reaching up to our graduation, then post-graduation, and if you are going for higher studies, for taking up research and all. This is a long-term process. But when it comes to the competitive examination, in a short span of time, you are preparing for getting a job. So this preparation, the strategy will be different. Exactly the same way as you know, in a test match cricket and in a T20, the strategies will be different. In T20, there will be no set rules, right? The only role is to score maximum and contain your opponents behind you, right? So there is no draw cases or anything like that. Similarly, in competitive examination also, there is no first class or distinction kind of demarcation or anything. Only thing is that out of the total competence, you should be on top, so that you will make sure that you will get that desired job which you are looking for. So in such scenario, time is the most crucial part. We may not be going through the conventional methods. We may not be going through the theorems or anything which we have learned during our school time or the college times. Even sometimes we may be going through choice elimination method, through going through the choices and all. So there will be lots of different techniques for reaching to the answer. So the method which we are opting for reaching the answer is, it doesn't matter. The only thing which matters is that within the allotted time, whether you are able to, reach to the correct answer and you are able to score maximum in that examination. That is the only thing which matters. So in such scenario, you should be able to, play some short tricks and such things. So all these short tricks, when it comes to the short tricks, this is not coming from air. The base is our theoretical mathematics only. From there only, all these shortcuts, everything is getting developed. But we are applying it into certain different levels, depending on the questions that are being asked. In our normal, academic studies, in every problems when we are doing, we will follow certain steps, right? For example, we will assume or we will presume this particular thing is X. Then based on the value we are assigning to X, we will develop step by step, and finally we will reach the final answer. But here in competitive examination, what we are looking for is, if possible, even without taking up your pen and paper, you should be able to reach the answer. So in this session, we will discuss such shortcut techniques, and tomorrow also we will continue. In tomorrow's session, we will be discussing again some different areas of competitive examination maths, and along with that we will discuss about the different competitive exams that any graduates can apply, so that you will get to know after your graduation what all exams you can apply for and what all are the job profile if you are clearing such exams. And also tomorrow there will be some shortcut techniques related with the Vedic mathematics, as another teacher and Biju sir already pointed out. That thing also we will discuss. And even in today's session, some applications of Vedic mathematics we will be dealing with, but a separate session for Vedic mathematics shortcuts and all, that we will discuss in tomorrow's session, because today's session is a little bit longer session where I have to cover certain things related with the number related problems. The reason why I am choosing number problems in the first day itself, because if you are started loving numbers, especially the bigger numbers, then automatically if somebody is fearing about mathematics, all those fears will that fears will be going right now, because most of the people will be fearful about dealing with higher numbers and its operations, different kinds of operations. So we will make sure that whatever the higher numbers, the calculations won't be an issue if we learn some short techniques and some tricks. So without waiting for so long, let's start our today's session. And I'm just now sharing my screen so that you will be able to see my screen and you can see the questions, right? Also, there will be a session after my this today's class is over, where based on today's session some questions you will be given, and you will be getting 20 minutes for attending 10 questions. So the college management is providing some surprise gift based on those who are answering those questions on a first come first basis. So whoever is finishing their questions at the earliest, they will be the winners. So attend this session carefully. Once the session is over, you will get a chance to ask your doubts also. In between, we are not entertaining such doubts, because if this many people if started talking in between, it will be really difficult for others to concentrate. So in between the session, all others mics will be muted. Once the session is over, you will be getting some 15-20 minutes to clear your doubts, and after that there will be some 10 questions related with today's session, and you will be getting 20 minutes for solving those questions. Okay, so listen carefully each and every concepts that which we are discussing. Once the concept is clear, you will be able to solve all these questions very easily. Fine. So I hope you can see my screen right now. Fine. So at first we are discussing with finding number of zeros at the end of any product. For example, one question is provided here. You can see here, find the number of zeros at the end of the product, 1 into 2 into etc. up to 10. So whenever such a product is given, our aim is to find out the zeros. Those are coming at the end of this product. For example, 100, there are 2 zeros at the end. And if we are taking 5,000, there are 3 zeros at the end. If you are taking 1,50,000, there will be 4 zeros at the end. So zeros at the end means all these zeros we are counting. But for example, if 1,050, number of zeros at the end, then there is only 1 zero. don't count this 0 also in this case, because we are asking for finding out the zeros. Those are coming at the end of the product. So these all are the zeros. Those are coming at the end of the product. So if you can solve it, you can solve it from your own, and you can take up a paper and a pen also, because this is going to be an interactive session, and each and every questions and the concepts which I am discussing, if you can note it down and you can solve it your own, that would be better. Okay. So I hope you understood the question very well. The aim is to find out the number of zeros at the end of the given product. Okay. So before we proceed, we should learn some basics. How we are getting a zero when we are taking up a product. How we are getting a zero. So a zero, as you can see here, a combination of some, we can say precisely 2 into 5. A 0 is a combination of the product 2 into 5, right? Then someone may be, having some doubts. Why is it not 4 into 5 or 6 into 5 or 8 into 5, something like that? I will explain. The reason why we are taking 2 into 5, because in this 4 into 5 also we can split it like 2 into 2 into 5, right? This 4 into 5 we can split it like 2 into 2 into 5, and here this 2 into 5 is becoming 10, and that 0 which we are getting there, that is continuing, and this 2 has no role in providing that 0, right? Similarly, this 6 into 5 in this case also we can split it like 3 into 2 into 5, correct? 6 we can split like 3 into 2, then into 5 we will be getting 30. There is a 0, but that 0 is already obtained when we multiplied this 2 into 5, and when we are again multiplying with 3, there is no other 0 coming, so that 3 has no role in providing a 0 there. Clear? So the first thing, the very basic things that we need to understood is a 0 is the combination of product 2 into 5. Clear? Now we are moving further. Suppose if we are given a product like 2 square into 5 square, and we need to find out the number of zeros at the end of that product, then we know 2 square means 4 and 5 square means 25, right? And 4 into 25 we will get 100, and we came to know that 2 zeros are there at the end of this particular product. So you can observe here the power value of 2 is 2 and the power value of 5 is also 2. So is there some relationship with the zeros at the end of the product and the power value which is given here? Yes, there is a relation. So this power value means we can take up 2 2s and 2 5s, right? So one pair of 2 and 5 will provide 1 0. So when it comes to 2 pair of 2 and 5, there will be 2 zeros at the end of the product. It is as simple as that. Okay, so if there is 5 pairs of 2 and 5 pairs of 5s, then there will be 5 zeros at the end of the product. So again you can see here the power value of 2 is 3 and the power value of 5 is 2, but still in the end of the product you can see only 2 zeros are there. Why is it so? From this we know that there are 3 pairs of 2s, right? 3 2s we can take, not pairs, 3 2s we can take, 2 into 2 into 2, that is 2 cube, and we can also take 2 5s, right? 3 2s and 2 5s. But when we are pairing a 2 with 5, this will be something like this: 2 into 2 into 2 into 5 into 5, right? So we can pair this 2 with this 5 and this 2 with this 5, and one 2 is there, the 2 has no friends, So there is no pairing with 5 is happening there. So even though the power value of 2 is 3, there is only 2 5s are there. So we can pair with 2 2s and 5s, right? That is the reason why only 2 zeros are coming here at the end. Again, next scenario. Here the power value of 2 is 2 and the power value of 5 is 3. So in this case also, there are 2 2s and 3 5s. But when we pair, only 2 pairs are possible, right? 1 5 will be there without any 2 4 pairing. So in this scenario also there will be only 2 zeros coming at the end of the product. Now coming to the last example, 2 cube into 5 cube. Here it is very much clear that we have the power value of 2 as 3 and the power value of 5 is also 3. So there are 3 2s and 3 5s there. So final product will become 2 cube 8 into 5 cube 125. The final product will become 1000, right? So at the end we will be getting 3 zeros. So from these examples, the basic things that we need to understood is the power values of 2 and 5 has a direct relationship in determining the number of zeros at the end of the product, and the minimum power value, whatever it is coming, that will be the number of zeros which is coming at the end of the product, right? See, in all these examples you can see the minimum power value, that is the one which determines the number of zeros. In the first case, the power value of 2, 5 both are same. So there is no doubt which one to choose from, because both are same, so 2 zeros will be there. In the next case, there will be 3, the power of 2 is 3 and the power of 5 is 2. The minimum value is 2, so there will be 2 zeros at the end of this product. And in the next case also, the power value of 2 is 2 and the power value of 5 is 3. The minimum value of the power values is 2, so 2 zeros will be at the end. And in the next case, both power values are same, 3. So at the end there will be 3 zeros. Now I am sure you can easily identify the number of zeros if the power values are known. For example, if 2 raised to 5 into 5 raised to 3, if it is given, you can easily say that at the end of this product there will be 3 zeros. Why? Because the power value of 5 is minimum, that is 3. So there will be 3 zeros at the end of this product. If 2 raised to 10 into 5 raised to 12 is given, 2 raised to 10 into 5 raised to 12 is given, then we can easily identify the power value of 2 is minimum. So there will be 10 zeros at the end of this product. So our purpose is to find out the power value of 2 and 5 from the given product. Then we can easily find out the number of zeros at the end of that particular product. Clear? Now the main question coming. It is easy if it is given in this format, but in the actual condition, in the actual exam condition, the questions will be coming like this. There will be a continuous series or a random series which will be provided, something like this. This is a continuous series, 1 into 2 into etc. up to 10, a consecutive series, and we need to find out the number of zeros at the end of this product. So here the power value of 2 or 5 is not directly given. So this being the first question, I will solve this in a detailed manner, and after that we will come to the shortcuts. Then only we will get to differentiate the time that we are seeing when we are applying the shortcuts, right? So in this product, if we take the power values, see, from here we can take a 2, we can say 2 raised to 1, and this 4 we can take it as 2 square, and 6 we can take it something like 2 into 3 or 2 raised to 1 into 3. Fine. And this 8 we can take it as 2 raised to 3. Then this 10 we can take it something like 2 raised to 1 into 5, right? So when we are multiplying this by applying the rule that we have studied in our 7th or 6th standard, the law of exponents, if we are applying a raised to m into a raised to n, the same rule, we will get to know that 2 raised to 1 into 2 square into 2 raised to 1 into 2 cube into 2 raised to 1. What will be that? 2 raised to 1 into 2 square means 2 cube. Then 2 square into 2 raised to 1 will be 2 raised to 4. Then 2 raised to 4 into 2 cube will be 2 raised to 7. And 2 raised to 7 into 2 raised to 1 will be 2 raised to 8, right? 2 raised to 8. So our power value of 2 in this particular product is 2 raised to 8. When we are multiplying all these things together. Similarly, if we take the power values of 5, see, from here we can take 1 5, and from this 10 we can split it something like 2 into 5, right? Which we have already splitted here. So only 2 5s are there in this, throughout this product, only 2 5s that we can take. So 1 5 is here and 1 5 is here. So in this product, the power value of 5 will be 2, right? 5 square. So the rest of the numbers power value we are not taking care, because those power values in any way not contributing for providing a 0, right? So we are not at all considering those power values. We are only concerned about the power values of 2 and 5. So from this series which is given, we came to know that the power value of 2 is 2 raised to 8 and the power value of 5 is 5 square. So we can simply write something like 2 raised to 8 into 5 square. Now you can easily say that how many zeros will be at the end of this particular product. Comparing the power value and take up the minimum value, it will be 2 only. So there will be 2 zeros at the end of this product. So if you are doubtful, you can check in your calculator. That's why I took this small series to start with. 1 into 2 into 3 into 4 into etc. up to 10. If you take up that product in the calculator, also you can see that there will be only 2 zeros at the end of the product. So this is a lengthy process. This is the way when we are doing it in our school classes or college classes. This is the normal practice we are doing step by step. Theory, we are applying that theory and then we are reaching to the final answer. Okay. So I hope till now everyone is clear. If any doubts, you can raise your hand so that the coordinators of this session, they will unmute you and you can ask your doubts. Anyway, we are proceeding to the shortcut for this. So let's move ahead. So now this type of a series is given to us. We need to find out the power value of 2 and 5 easily without going through the series. And if it is a long series like 1 into 2 into etc. up to 1000 or 5000, then it is not practically possible to write it and find out the power value of 2 and 5. So there should be some short tricks, right? I am coming to that short tricks. So finding out the power value of 2 and 5 in a consecutive series starting from 1, we are taking the last digit, last number. So here the last number is 10. So I took 10 here and now I am going to divide it successively or continuously with the number whose power value I need to find out. So here I need to find out the power value of 2. So I am dividing this series with 2. So 10 divided by 2, I will be getting 5, right? I am not stopping here. Again I am dividing 5 with 2. Then the remainder you can avoid. You need to take only the quotient. So 5 divided by 2, the quotient will be 2 and remainder is 1. Remainder you can avoid. No need to take the remainder. Once again I can divide this 2 with 2. Now I will get the quotient as 1. And now I am not able to divide it further so that it comes to the last point. It comes to 1. Now I won't be able to divide it further, right? So once this thing is over, what we will be doing, we will be adding up all the quotients that we got. So the first quotient that we got is 5, the second quotient is 2, and the third quotient is 1. If you add all these three together, what you will be getting? 5 plus 2 7, 7 plus 1 8, right? So that 8 is the power value of 2. So you can write 2 raised to 8. When you are taking up this product, the power value of 2 will be 8, or it will be something like 2 raised to 8. And we need to find out the power value of 5 also. So again we will take this last number 10, we will divide it with 5. The quotient that we will be getting is 2, and further division is not possible because 2 is lesser than 5. So you cannot divide 2 with 5 again, right? So we are stopping in the first step itself. Only quotient is 2. So the power value of 2 will, the power value of 5 will be 2 in this product. So we can say that the power value of 5 is 2. So we, without even directly going through each and every, products of 2 and 5, directly we will get the power value of 2 and 5, something like 2 raised to 8 and 5 square. Once you reach to this point, the minimum value is the answer. So the minimum value is 2. So the number of zeros at the end of this product will be 2. Clear? So I am making it further simple. There is no need to find out the power value of 2, because whenever we are dealing with a consecutive series starting from 1, the power value of 5 will be always minimum. The reason is, if you go through this, you can easily find out every second term you will be getting a multiple of 2, right? Every second term you will be getting a multiple of 2. So obviously the power value is higher, because the 5s are coming once in 5, or once we pass through 5 terms, then only the multiple of 5 is coming. So obviously the power value of 2 will be higher when we are dealing with a consecutive series. So there is no need to find out the power value of 2, because you need to find out the power value of the minimum power value, right? So when we are dealing with this, the minimum power value will be always the power value of 5. So you can directly find out the power value of 5, and that will be the answer. Clear? So if such a question is coming, what you will be doing? Your first step will be this one, and this will be your answer. When you are getting 2, you can say that this is the answer. There will be 2 zeros. Now instead of 10, 50 or 1000 or 100 or 10,000 or whatever it is coming, you can easily find out the answer. So now we can do problems one by one. So once again we can go through the things. This was the first question. So what we will be doing, we will take up the last number of that series, we will divide with 5. Our quotient is 2, so there will be 2 zeros at the end of this product. That is it. And now next question, here we need to find out the number of zeros at the end of the product, 1 into 2 into etc. up to 100. The rule is same. You will take the last number, that is 100. Now you will be dividing it with 5. Then the quotient is 20. Again you will be dividing it with 5. You will divide it till the last point where further division is not possible. So now we are dividing 20 with 5, we will get 4. Now further division is not possible because 4 is less than 5. So we cannot divide 4 with 5. We are stopping here. 2 quotients are there, 20 and 4. We need to take the sum. We will be getting 24. So our answer is 24. That's it. So when we are multiplying 1, 2, etc. up to 100, the number of zeros that are coming at the end will be 24. 24 zeros will be there, right? So next question I am not doing. You will be doing 1 into 2 into etc. up to 1000. You can do it, and you can put your answer in the chat box, so that we will get to know whether you understood the concept or not. I would request the coordinators for enabling the chat box, so that each and every participant, they can provide their answer there. Also, I'm just turning off my video so that the screen will be fully visible. Just a second, give me just 1 second. I'm waiting for your answers. No answers so far. If your chat box is enabled, please type your answer. Okay, let's see the answer. Here the last number is 1000, right? So what we will be doing? We will divide 1000 with someone else is typing in between, I think. Just a second. Okay, fine. So 1000 divided by 5 we will be doing. Divided by 5. I think someone else is pen is there active. That's why I am not able to write it here. Sri Priya's pen is active. That's why I am not able to write it here. Fine. So 1000 divided by 5, you will be getting 200, right? 200. Again you can divide with 5, you will be getting 40, right? And again if you are dividing with 5, you will be getting 8. And once again you can divide. So dividing 8 with 5, you will get 1 as quotient, right? Now the division is over, further division is not possible. So our answer will be 249. When we are adding up all these things, our final answer will be 249. Okay, so first we will divide 1000 with 5. 200 is the answer. Then 200 divided by 5, 40. Again 40 divided by 5, 8 is the quotient. Now 8 divided by 5, the quotient is 1. and further division is not possible, and the final answer is 249. Clear? So next question, 1 into 2 into etc. up to 36. 1 into 2 into etc. up to 36. See, there can be a doubt for some students at least if it is a series which is not ending with 0, because the other series which we have already discussed, 1 into 2 into etc. up to 10, then up to 100, something like that. But this is ending with a normal number like 36 where there is no zeros in this series, right? So in that case also you can adopt the same method. 36 divided by 5, when you will be doing 36 divided by 5, 7 is the quotient, right? 7 into 5, 35, remainder 1, that we can avoid. Again 7 divided by 5, the quotient is 1, right? So further division is not possible. 7 plus 1, answer is 8. So there will be 8 zeros at the end of this product. There will be 8 zeros at the end of this product. Now let's move to the next question. 1 into 2 into 3 into etc. up to 27. You can do it along with me. Simultaneously we can do the question. So 27 also, 27 divided by 5. What will be our answer? 5, right? Quotient is 5, remainder is 2. Let's remove the remainder, only focus on the quotient. Now again 5 divided by 5, our quotient is 1, right? So the final answer will be 5 plus 1, 6. So there will be 6 zeros at the end of this product. Now coming to the next question, this is something like 1 into 3 into 5 into 3 into 25. Can you find out the number of zeros at the end of this product? See, these are some tricky questions where once you learn some rule, you will blindly follow such rules, even without taking care of the questions, or even without carefully examining the question. If you are applying the rule, you will be in trouble. In competitive examination, most of the time there will be some traps. In those traps, if you are putting in those traps, you will be in trouble. So here also, normally what people will do, take 25, then will divide with 5, again once again divide with 5, quotient is 1, and find the answer as 6, which is wrong. Why? Because this is, first of all, this is not a natural number series, consecutive series, right? This is odd number series, 1 into 3 into 5 into etc. And second thing is that when some odd numbers are being multiplied, in no such cases we can reach to a 0, because 0 is a combination of 5 into 2. When there are no 2's or no even numbers, it is not possible to reach to a 0. So at the end of this particular product, there will be no zeros, no 0 at the end of this product. So you should be careful when you are applying the rule. This rule is applicable only when we are starting from 1 and the series is a consecutive natural number series. Then only we can apply this rule. Otherwise this rule is not valid. Okay. So in this scenario, the answer will be no 0. And before we do this problem, I will show one more problem. This is also something similar problem. 1 into 3 into 5 into etc. up to 99 into 32. But here there will be 0, because up till here there is no option for getting a 0, because this is an odd number series, right? Odd number series, and there is no possibility of a 0. But at the end of the product, we are multiplying it with 32, an even number. That means there is a possibility of getting some zeros. So in such case, what we will do, we will find out the prime factor of 32. We will split 32 like, we will divide it with the 2. So then we will be getting 16. Again we will divide it with the 2. We will get 8. Again with the 2. We will get 4. Again with 2. we'll get 2 and once again with the 2 and it's over, right? Or we can write 32 is equal to 2 raised to 5, right? 32 can be written as 2 raised to 5. And the rest of the part, anyway 5s are coming in between, right? So here 1 5 is here and another 5 will be 15, then 25, 35, 45. All these odd numbers are multiples of 5s are coming, those numbers will be coming in between. 55, 65, likewise up to 95 it is going, right? Up to 95 it is going. So what will be the power value of 5 in this case? See, 1 5 is here. You can take 1 5 from here and 25 means 5 square. Again 35 means 7 into 5. From there also you can take 1 5. 45 means 9 into 5. 9 into 5. So up till now we have already passed the power value of 5 larger than that of 2's power value, right? Because we need to find out the minimum power value only. So the power value of 2 is 5. But the power value of 5, if you calculate 1 from here, 1 from 15, 2, then 5 square, 25 we can take it as 5 square, then 5 square into 5 square, 5 raised to 4. When you are reaching 25, the power value of 5 is 5 raised to 4. And again when we are coming to 35, one more 5 is there. Now the power value of 5 is 5 raised to 5. When you are coming to 45, the power value of 5 is 5 raised to 6. Now there is no need to move further because already the power value of 5 reached to the point 5 raised to 6. Whereas the power value of 2 is only 2 raised to 5. So the minimum value is 2's power value only. So the number of zeros is the minimum power value. So their minimum power value is the power value of 2, which is 5. So at the end of this product there will be 5 zeros. 5 zeros will be there at the end of this product. So in such scenarios you have to take it separately and find out the answer, but 99% case you will get a continuous consecutive series. So you can directly apply the rule there. If some random numbers are given, then in such case you have to find out the power value of 2 and 5 separately. Then you have to compare with that and you have to go with the minimum power value. That will be the answer. Clear? So one more question. You can do it yourself. In this case also you have to find out the power value separately. I'll give you 1 minute. You can do it yourself. So I hope all of you have reached to the correct answer. Let me see. So our intention is to find out the power value of 2 and 5, right? So this 6 you can write it something like 2 into 3. 4 is 2 square. 8 is 2 cube. 5 is 2 into 5. 15 is 3 into 5. 12 is 2 square into 3. Again another 15 is there, that is 3 into 5. Another 16 is coming there, that is 2 raised to 4. Now 18 again 2 into 3 square. 20 2 square into 5, again 2. So it is obvious that the power value of 2 is more here, so there is no need to find out the power value of 2 because we need to find out the minimum power value only. So minimum power value when we are taking 1 5 is here, another one is here, another one is here, so 3 5s are there, 1 is here, 4 5s are there, right? No other 5s are left. So the power value of 5 is 5 raised to 4. That means 4 zeros will be there at the end of this product, right? We can take only 4 5s from this product. So the final answer, the number of zeros at the end of this product will be 4. Clear? So when random numbers are given, you have to split it in this way. Then you have to find out the minimum power value. That will be the answer. Now we are moving to a further to the next type. Here an even number series is given, 2 into 4 into 6 into etc. up to 100. So here we can split this something like 2 into 2 into 2 into 2 into 3 into 2 into 4 into etc. up to 2 into 50, right? 2 into 50. I have taken 1 2 from every component. So 2 instead of 4 we have written 2 into 2. Instead of 6 it is 2 into 3. Instead of 8 it is 2 into 4. Likewise instead of 100 it is 2 into 50. So these 2's we can take it out, but unless addition, this is multiplication. So each 2 has its own value. When we are taking up 2 as a common outside the bracket, it should not be 2. It will be 2 into 2 into 2 into 2 into etc. 50 times 2, right? So the outside value will be 2 raised to 50, and now within the bracket you can write 1 into 2 into 3 into 4 into etc. up to 50. Clear? See, we have taken 52s outside. So 52 product will become not 100. It is 2 into 2 into 2 into etc. up to 50. That's why the product is 2 raised to 50. And the remaining items are from this term. If 1 2 is outside, that means 1 is left. From here 2 into 2, if 1 2 is out, that means other 2 is left there. And from 2 into 3, 1 2 is outside, then 3 is left there. Likewise from 2 into 50, the 2 is outside, that means 50 is inside, right? So this will become something like 2 raised to 50 into 1 into 2 into 3 into 4 into etc. up to 50. So we know that when we are dealing with a consecutive series, the power value of 2 is minimum. Sorry, the power value of 5 is minimum. And already the power value of 2 is 2 raised to 50, which is coming outside also. Apart from this 2 raised to 50, there will be some 2's left inside this bracket also. So the power value of 2 will be definitely higher. So no need to find out the power value of 2 here also. We just focus on the power value of 5. For that, what we need to do? Now we are getting a consecutive series where we can apply our rule within the bracket. So 1 into 2 into 3 into etc. up to 50. This is a consecutive natural number series starting from 1. So we can apply our rule which we have initially studied. So what we will do? 50 divided by 5, because we know that the power value of 5 will be minimum. So we just need to divide it with 5. So 50 divided by 5, what we will be getting? 10. Again we will divide with 5. We will get 2. Further division is not possible. The final answer will be 10 plus 2. 10 plus 2 means 12, right? So the final answer, the number of zeros at the end of this product will be 12. Clear? So we are moving further. Same type of question, you can apply it yourself. We can do it something like this. Instead of 2, you can take 4 as common, right? We can make it like 4 into 1 into 4 into 2, etc. up to 4 into 500. 4 into 500. So when we took this 4 outside the bracket, it will be something like 1 into 2 into 3 into etc. up to 500, etc. up to 500. Now this is a consecutive series, and outside the bracket there is no 5s are coming, so we need to find out the power value of 5 from within the bracket only. Outside, if there are some other 5s are there, we need to calculate that as well. But here it is obvious that only 5s are coming within the bracket only. So the power value of 5 will be 500 divided by 5. We will get 100. Again divided by 5, we will get 20. Again divided by 5, we will get 4. That's it. Further division is not possible. So 100 plus 20 plus 4, our answer will be 124. So the number of zeros at the end of this product will be 124. Number of zeros at the end of this product will be 124. We are moving further. This is a little complicated problem, this one. You need to be careful when you are solving this problem. Same method we are applying, but some indirect aspects are there. Let us see how we will do this question. See, in this case, if you are taking 5 outside, it will be something like 5 into 1 into 5 into 2 into 5 into 3, etc. etc. up to 5 into 50, right? 5 into 50. 5 into 50. So 50 5s are there. One 5 is here, second 5 is here, third 5 is here. Likewise, the 50th 5 is here. So when we are taking all these 5s common outside the bracket, it will be 5 into 5 into 5 into. That means 5 raised to 50 is outside, and within the bracket it will be 1 into 2 into etc. up to 50. Right? 1 into 2 into etc. up to 50. So if we are considering within this bracket only, that means automatically the power value of 5 is minimum. There is no doubt about it. But already 5 raised to 50 is outside also. So when 5 raised to 50 is outside and some power value, for example, if 5 raised to x is coming from inside, the final answer will be 5 raised to 50 into 5 raised to x. That means 5 raised to 50 plus x, right? So the power value of 5 will be more here, because anyway the power value of 2 cannot be more than 50. That is another rule. When we are dealing with a consecutive series, the last term here it is 50. So the power value of 2 when we are taking, it will in any case will be less than 50 only. And already the power value of 5 is 50, which is already outside, it is there, and something from inside is also coming, then automatically the power value of 5 will be more. So here instead of 5's power value, we have to find out 2's power value, because our aim is to find out the minimum power value. So minimum power value in this scenario, it is not 5, it is 2 only. In the previous question we have already seen 1 into 2 into etc. up to 50, the power value of 5 is 12, right? So if coming to this bracket, if we are taking 1 into 2 into etc. up to 50, the power value of 5 is 5 raised to 12, and outside of 5 raised to 50 is there. So 5 raised to 50 into 5 raised to 12, it will become 5 raised to 62, right? 50 plus 12 means it will be 5 raised to 62. But when we are dealing with the 2, it is certain that in any case the power value of 2 will be less than 50. So let us find out that the power value of 2 here. We will take this last one, that is 50. So 50 divided by 2 means 25. Again we will divide with the 2. This will be 12. Again we will be dividing with the 2. This will be 6. Again dividing with the 2, we will get 3. Once again we can divide with the 2. Final quotient is 1, right? So these all are our quotients. Remember, first time 50 divided by 2, the quotient is 25. Again 25 by 2, quotient is 12 and remainder is 1. We are removing the remainder, then quotient is 12. 12 divided by 2, the quotient is 6. Again 6 divided by 2, the quotient is 3. And 3 divided by 2, the quotient is 1. We need to add up all these quotients, then it will become 25 plus 12, 37. 37 plus 6, 43. 43 plus 3, 46 plus 1, 47, right? So the power value of 2 is 2 raised to 47 only. So here we can find out that the minimum power value is that of 2's power value. 5's power value is 62, where 2's power value is 47 only. So the number of zeros at the end of this product is 47. Number of zeros at the end of this product is 47 only. Okay. So one more problem. This one you can do it yourself. The last one of this type, and after that we will move to the next type. Find the number of zeros at the end of the product. 10 into 20 into 30 into etc. up to 500. One minute for you. You can do it yourself. Okay, let's do it. So here we can split it something like 10 into 1 into 10 into 2 into 10 into 3 etc. up to 10 into 50, right? 10 into 50. So from each time we can take out tens outside. That means 50 tens are outside. So this will become 10 raised to 50, and inside it will become 1 into 2 into 3 into etc. up to 50, right? 1 into 2 into 3 into etc. up to 50. So if we go through this one inside, anyway the power value of 5 will be minimum. That means 1 into 2 into 3 into etc. up to 50. When you are dividing 50 with the 5, you will be getting 10. Again with 5, you will be getting 2. So final answer will be 12, right? So here you will get the power value of 5 as 5 raised to 12. 5 raised to 12. But even though the first choice also will be 12, but you should not, go to that answer. There is some hidden items here. This 10 you can split it something like 2 into 5, right? You can split up this something like 2 into 5. So you can write it something like 2 into 5 the whole raised to 50. So outside 10 raised to 50 means it is 2 into 5 raised to 2 into 5 the whole raised to 50. 2 into 5 the whole raised to 50 means 2 raised to 50 into 5 raised to 50, right? Because in the law of exponents we are already studying AB the whole raised to m is a raised to m into b raised to m, right? By applying the same logic here, it is obvious that 2 into 5 the whole raised to 50 is 2 raised to 50 into 5 raised to 50. So here both 2's and 5's power values are same, and inside this bracket we are clear that 5's power value is minimum. So when we are adding this together, automatically the 5's power value is minimum, because inside 2's power value is very much higher than 5's power value inside this bracket. So if those values are coming outside, 2 raised to 50 into that 2 raised to 47 it will come up, then it will be something like 2 raised to 97, right? But 5's power value 5 raised to 12 is there inside and some 5 raised to 50 is outside. So together this will become 5 raised to 50 into 5 raised to 12. 5 raised to 50 into 5 raised to 12 means 5 raised to 62, right? 5 raised to 62. The final answer will be 62 zeros at the end of this product. 62 zeros at the end of this product. So these are some of the higher level problems. Normally this type of problems, it won't be coming there for most of the competitive exams. But still I am dealing with the mathematics graduates and the teachers who are well aware of these basics of mathematics. That's why little bit higher level problems also we are dealing. Okay. Otherwise there is no need to go through these higher level problems. 99% case, as I told you, the very basic questions, direct series will be coming there. This type of complicated series won't be there. Okay. So before we move to the next type, there is one more question. Instead of the product, this is a sum. So we need to find out the number of zeros at the end of the sum, 10 factorial plus 50 factorial plus 100 factorial. This is again a simple question, a tricky question. Some traps are there in this type of question. Even with people, those who are having, good knowledge in mathematics, sometimes they will, fell in this trap. When they are in the actual exam condition, where when they are doing this, they will be in some type of, some carelessness or something happens. Definitely they will make some mistakes. So let us see what will be the correct answer. 10 factorial, we know it is nothing but 1 into 2 into etc. up to 10, right? Likewise, 50 factorial is 1 into 2 into etc. up to 50. And 100 factorial is 1 into 2 into etc. up to 100. You already know in this format, if it is given the number of zeros, you already know how to find it out. So 1 into 2 into etc. up to 10, the number of zeros is 2. Already we have done that question in the first question itself. And again 1 into 2 into etc. up to 50, the number of zeros is 12. That is also already done. And up to 100 it is 24, which is already done. Right. In previous questions we have discussed with this. We are just dividing the last term with 5, and the quotients that we are getting, we are adding up. These are the number of zeros. So the first choice will be 37. And those who are doing so far without making any mistake, after doing this, they will come to the wrong answer. What they will be doing, since addition is given here, will add all the number of zeros. So up to 10 factorial 2 zeros are there, up to 50 factorial 12 zeros are there, and up to 100 factorial 24 zeros are there. So all these zeros adding together, it will become 24 plus 12 into 2, that becomes 36 plus 2, sorry, it will be 38, right? 24 plus 2, 12, 36, and 36 plus 2, 38, and this is the wrong answer. Why? When I am writing a simple example, you will came to know why this answer is wrong. I am adding up some numbers ending with 0. See, in the first number there are 5 zeros at the end. In the second number only 2 zeros are there, and in the third number only 1 zero is there. When we are adding this, unit place there will be 0, and whenever the non-zero part is coming, from there onwards in the addition there will be no 0. So at the end of this sum, no need to do rest of the things, because our only aim is to find out the 0 at the end. So the 0 at the end is the minimum number of 0, right? That means when we are getting these type of this kind of numbers, wherever the minimum 0 is there, that will be the zeros coming at the end of the sum. When it is sum, minimum number of zeros for any number, if we are adding up that, at the end of the total sum also, that those many zeros will only be there. Clear? So here minimum number of zeros is 2 for 10 factorial. So now whatever we are adding, the minimum value is 2. That means there will be only 2 zeros at the end of this sum. Only 2 zeros at the end of this sum. Hope this is clear to you. So by this question we have completed this finding out the number of zeros at the end of any product or sums like this. Okay. One more thing, if instead of plus, if it is into here, that means we are taking the product, right? In that case, we will add up all these zeros. So the final answer will be 38. If instead of addition, if it is multiplication, total number of zeros will be 38. Because when we are multiplying, we know that if 10 into 50 into 100 we are doing, what we are doing, we will take up all these zeros and put it in the final product, right? The same is the scenario. So when if it is product, we need to add all the zeros. If it is sum, we will take the minimum 0 term only. Clear? That's it. So now we are moving to the next type, finding the unit digit of some higher order numbers like which is given in the screen. So sometimes this type of questions also will be coming. Find the digit in the unit place of 7 raised to 59 raised to 85 into 3 raised to 78 into 34 into 3 raised to 87 into 53. So anyway, this is not possible to find out the product of this number and then find out the unit place, right? Why is it not possible? Because if we are doing that, this entire space won't be available, won't be sufficient, right? Leave it 759 raised to 85. If you need to find out 9 raised to 85, even that is not possible, right? So without finding the value, we are finding the unit place. There are certain tricks to find out. So we will come back to this problem. So before we are coming to this problem, we need to learn some basics. So our basics needs to be something strong so that we will be able to find the answer easily. So here, the digits from 0 to 9, we are classifying them into three different groups based on their characteristics. So the first group is 0, 1, 5 and 6. These digits, they have their own special character. The reason we are putting these together is any number, whatever number, big or small, whatever number we are taking, in that scenario, if the unit place is 0, 1, 5 or 6, whatever power for that number, power value is whatever, the unit place of the final result will be these numbers itself. I will explain it through an example. First, let us consider a number ending with the 0. If we are taking 10 raised to 1, answer is 10. If we are taking 10 square, answer is 100. If we are taking 10 cube, answer is 1000. In all these cases, the unit place is 0 itself, right? Because when we are multiplying, it will be something like 0 into 0 into 0 into 0. The first multiplication is with the 0 only. So the unit place will definitely be 0. And even we are multiplying this with any other number, then also the unit place will be 0 only. So when we are dealing with 0, 1, 5 and 6, whatever is the power of that number, power value of that number, the final value or the expanded value, unit place will always be the same number only. Another example we can take, if it is 1, suppose if it is 11 or 21 or 31, whatever it is, a power value means it can be something like 11 square or 11 cube or 11 raised to 4 or something like that, right? We can take it up something like 21 cube, 31 raised to 4 or something like that. So when we are multiplying, it will be something like 11 into 11 or 21 into 21 into 21 or 31 into 31 into 31 into 31. Fine. Do we need to find out the final value for finding out the unit place here? Because unit place anyway in multiplication, it will be the product of this unit place, right? So 1 into 1 into 1 into 1 will always be 1. Here 11 into 11, it is 121, unit place is 1. So even without finding out the product, we can say that here the unit place will be 1 only. Similarly 21 into 21 into 21 also, the unit place of that product will be 1 only. This is the same case with the 5 and 6 also. Any number ending with the 5 or 6, whatever is the power, expanded terms unit place will be, if it is 5, expanded terms unit place also will be 5, and if it is 6, expanded unit place is 6, right? So here again, if it is something like 25 into 25 or something like that, the first multiplication will be 5 into 5, so it will end in 5 only. Similarly, if it is 36 into 36, again 6 into 6, it will end up in 6 only. So this is the particular character of this series, group 1 digits 0, 1, 5 and 6. If any number ending with 0, 1, 5 and 6, whatever is their power value, the expanded term, the unit place will be the same digit. Clear? So now if I am asking you, (2,500) raised to 75,000. Do we need to find out the final answer for finding out the unit place? No. We are not fearful about the larger number or whatever huge number it is. Only thing we will consider is here the unit place of this number is 0. So whatever power value is coming, the result will be some huge number ending with the 0 only. So the unit place of that final answer will be 0 only. Similarly, if 27,561 raised to, just a second, let me write this. Raised to any bigger number, whatever it may be. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, again 0, 1, 2, 3. Whatever bigger number, no issue. We know that the unit place will be 1 only. Because when we are multiplying this number those many times, the first multiplication is 1 into 1 into 1 into 1 into 1 into etc. up to that number. So how many times you multiply 1 with 1? Final product will be 1 only. So the unit place of that final expansion will be 1 only. Same case with 5 also. 275 raised to any number, any random number. Unit place of this expansion will be 5 only. Same is the case with the 6 also. So any group 1 number, if it is coming, now it is very simple. You can easily find out the unit place, right? Now we are dealing with the second group. Second group is 4 and 6. Four and 6. They are also similar in nature. That's why we grouped these two digits together. We know that 4 raised to 1, it will be 4, and 4 square it will be 16, right? And when it comes to 4 cube, it will become 64, and 4 raised to 4, it will become 256, right? 256. So one thing is clear from this expansion. Whenever the power of 4 is odd, it will end up in 4 unit place. And whenever the power of 4 is even, it will end up in 6. See, here again power of 4 is odd, unit place is 4. When the power of 4 is even, unit place is 6. Then what we can say? 4 raised to odd power, unit place will be 4. And 4 raised to even power, unit place will be 6. Same is the case with the, not 6, it is 9. Okay, it's a typing error. It is not 6, it is 9. 4 and 9. So same is the case with the 9 also. When we are coming up with the 9 raised to 1, we will get 9. 9 square we will get 81, where the unit place is 1. Again when we are going to 9 cube, it will be 81 into 9, right? 81 into 9, it will become 729. And 9 raised to 4, it will be 729 into 9. We need to find out the unit place only. Then 729 into 9 means 9 into 9, unit place will be 1 only. So in this scenario also, we can easily conclude that 9 raised to odd power means unit place is 9, and 9 raised to even power means unit place is 1, right? So 9 raised to odd power, unit place is 9, and 9 raised to even power, unit place is 1. So if you are clear about these two things, any number ending with 9 and 4 won't be an issue for you. It will be very much easy to solve such problems. Let us do some 2-3 examples. For example, if a number ending with 4. 24 raised to 5, 7, 6, 8, 9, 2, 3. Whatever bigger the power value, we don't, we are not afraid of the value of the number. We know the trick. We can easily solve it. Only thing we are considering is that if the number is ending with 4, the power is odd or even. If it is odd, the unit place of that expansion will be 4 only. And if it is instead of 3, I am adding 1 0 also here, then this become even, right? So now when the power is even, the unit place will be 6. That's it. So we are only considering whether the power is odd or even. When the power is odd, final answer, unit place of the final value will be 4 only. And when the power is even, the unit place of the expansion will be 6 only. That's it. If it is 5334 raised to any number, what we will be looking? It is ending in 4. Power is odd. So the unit place will be 4 only. That's it. And if 7, 3, 5, 6, 8, 4 raised to 1, 2, 3, 4, 5, 6, 7, 8. The number is ending with 4. Power is even. So the unit place will be 6 only. It is as simple as this much. There is no complication, nothing. We are just considering the power value is odd or even. Whatever the power value, if it is the number is ending with 4, the power value, if it is odd, unit place of the expansion will be 4 only. And if the power value is even, unit place will be 6. That's it. Okay. We can do some 2-3 examples with the 9 also. So when it comes to 9, let's do 729 raised to 5364. We are bothered about whether this is odd or even. Since this is even, the unit place is 1. And if another number, say 1689 raised to 1, 2, 3, 4, 5, 6, 7. So since this power is odd, the unit place of this expansion will be 9 only. That's it. So I hope this part is clear. So when we are doing rest of the practice problems, you have to apply these rules which you have learned. Okay. So one more group is left. Once we finish that, we can come back and solve some of the practice questions which is already there. Just a second. So this is group 3. When it comes to group 3, the leftover numbers 2, 3, 7 and 8, they are also similar in nature. This is the complicated group, we can say. It is not complicated, but still comparing to the other two groups, this one is the complicated group. Why? Because there is a cyclicity effect coming here. Cyclicity means after the 4th term, the unit place will repeat. See, for example, 2 raised to 1, the unit place is 2. Again, 2 square, the unit place is 4. And 2 cube, the unit place is 8. 2 raised to 4, the unit place is 6. Now again, when we are coming to 2 raised to 5, the unit place is 2. 2 raised to 6, again this is 4. 2 raised to 7, again this is 8. And 2 raised to 8, again this is 6. Right. And when it comes to 2 raised to 9, again 2, 4, 8, 6. So if any number ending with 2, based on the power value, the unit place will be either 2, 4, 8 or 6. These are the 4 options. Unit place can be 2, 4, 8 or 6. No other number is possible. When a number ending with 2, when we are taking any power, any of these 4 values will be coming in the unit place. So we can say that 2 raised to 1's unit place is same as that of 2 raised to 5's unit place, and it is same as that of 2 raised to 9's unit place. So after every fourth power, these things will be same, right? So the same is the case with the 3 also. 3 raised to 1 is ending with 3, 3 square 9, 3 cube 27, 7, and 3 raised to 4, 1. And if we are going to 3 raised to 5, unit place will be 3 only. If 3 raised to 6, unit place will be 9, and 3 raised to 7, unit place will be 7, and 3 raised to 8, unit place will be 1. So after the fourth time, again the same cycle will repeat. Same is the case with 7 also. 7 raised to 1, 7, 7 square 49, so 9, 7 cube, no need to find out the full value, only unit place I am writing. So 7 cube means 7 into 7 into 7. 7 into 7 ending with 9. So 9 is the unit place there. Again 9 into 7, unit place will be 3, right? 9 into 7, 63. 63 means unit place is 3. And 7 raised to 4 means we can split it something like 7 square into 7 square. So 7 square ending with 9. So another 7 square again ending with 9. So 9 into 9, it will end with the 1, right? So 7 square, it will be 7 raised to 4 will be ending with the 1. 7 raised to 4 will be ending up with the 1. Again when we are coming to 7 raised to 5, it will be 7. 7 raised to 6, it will be 9. 7 raised to 7, it will be 3. And 7 raised to 8, it will be 1. Unit place I am saying. Same is the case with 8 also. 8 raised to 1, unit place is 8 only. 8 square 64, that means 4 is there. 8 cube, so 64 into 8, unit place will be 4 into 8, right? 4 into 8, unit place will be coming to 2, right? 8 into 4, 32, so the unit place will be 2 here. And 8 raised to 4, 8 raised to 4 means either you can take it 8 square into 8 square or 8 cube into 8. In both case, it will be, if I am taking 8 cube into 8, it will be 2 into 8, 16, so unit place will be 6. And if you are taking 8 square into 8 square, 8 square into 8 square, in that case also it will be 64 into 64. 64 into 64 means unit place will be 4 into 4. 4 into 4 means 16, 6. Right? We are taking the unit place only, so no need to find out the final answer. So this is the basic structure of these 4 digits. 2, 3, 7 and 8. So for easy understanding, we are preparing a table. I will explain what this table is. If a number ending with 2, 3, 7 or 8, if the power value is 1 more than a multiple of 4, then unit place will be respectively 2, 3, 7 and 8. I will explain with an example. For example, if it is 122 raised to say for example 41, 122 raised to 41. So here it is provided the powers, okay. The powers are given here, powers. So If the power is 4n plus 1, that means the power is 1 more than the multiple of 4. See here 41, you can say 41 is 40 plus 1. 40 is a multiple of 4. So this 41 means the power is 4n plus 1. 4n plus 1. So we are just easily finding out what we are doing. We will find out the remainder of the power value when we are dividing it with 4. So 41 divided by 4, quotient is 10 and remainder is 1. If remainder is 1, that means it is 4n plus 1. So if it is 4n plus 1, we are saying the unit place will be 2 only. So when the number ending with 2, if the power is 4n plus 1, unit place of the expansion will be 2. And same case if it is 122 raised to the power 42. 42 divided by 4, remainder is 2. Right. Remainder 2 means our power is 4n plus 2 format. So if it is 4n plus 2, the unit place will be 4. Again, if it is 122 raised to 43, when we are dividing the power with 4, the remainder is 3. Remainder 3 means it is 4n plus 3 format. 4n plus 3, the unit place will be 8. And again, last one, 122 raised to 44 if we are taking. 44 is a multiple of 4, right? 44 is a multiple of 4. So we can say the power is 4n type. If the power is 4n type, unit place will be 6. So if the number is ending with 2 and the power is 4n plus 1, unit place is 2. If the number is ending with 2 and the power is 4n plus 2, then it will be 4. If the number is ending with 2 and the power is 4n plus 3, then the unit place is 8. If the number is ending with 2 and the power is 4n, that means a multiple of 4, then the unit place will be 6. Okay. We can easily remember these digits, no need to by heart it, I will come to that. Same is the case with 3, 9, 7, 1, 3, 7 and 8 also. If the number is ending with 3 and the power is 4n plus 1, unit place will be 3. If the number is ending with 3 and the power is 4n plus 2, then unit place will be 9. If the number is ending with 3 and the power is 4n plus 3, then unit place is 7. And if the number is ending with 3 and the power is 4n, a multiple of 4, then unit place will be 1. Okay. Similarly for 7 also and 8 also. So let me conclude how we can easily remember this, even without by hearting this. See, if you go through these things, this is nothing but 2 raised to 1, 2 square, 2 cube, 2 raised to 4. We have taken only the unit place, that's it. Here again, this is 3 raised to 1, 3 square, 3 cube and 3 raised to 4. The unit place of 3 raised to 1, 3 square, 3 cube and 3 raised to 4 we have taken. And this is 7 raised to 1, 7 square, 7 cube and 7 raised to 4 unit places. And this is 8 raised to 1, 8 square, 8 cube and 8 raised to 4 unit places. So in the first row, it will be the first power. In the second row, unit place of the second power. In the third row, it will be unit place of the third power. In the fourth row, it will be unit place of the fourth power. That's it. There is nothing to by heart. You just need to find out 2 square, 2 cube, 2 raised to 4. 7 raised to 1, 7 square, 7 cube, 7 raised to 4. Likewise, or 3 raised to 1, 3 square, 3 cube, 3 raised to 4. Even 3 raised to 4, you may not be knowing the value, no problem. You know 3 square into 3 square is 3 raised to 4. 3 square ending with 9, that means 3 raised to 4. It will be 3 square into 3 square, that means 9 into 9, so it will be ending in 1. Right? Similarly, if 8 raised to 4, you may not be knowing the value of 8 raised to 4, but you can easily conclude it is 8 square into 8 square. 8 square is 64, so 8 raised to 4 means 64 into 64. 4 into 4, unit place will be 6 only. Likewise, without by hearting, you can easily, remember these things. Easily remember these things. Now we will go back to the questions one by one and we will solve this. So all these things which we have learned, that should be there in your mind. So when we are coming to this first question, we need to find out the unit place of this product. So we know that a number ending with a 9, if the power is odd, the unit place will be 9 only. And a number ending with 8, this one, whether it is 4n plus 1, 4n plus 2, 4n plus 3 or 4n plus 4, that is what you need to find out. So 34 means you have to divide 34 with 4, the remainder is 2. Remainder 2 means it is in the second row, 4n plus 2. 4n plus 2 means 8 square, 8 square means 64, unit place is 4. Okay. And 7 raised to ending with 7 and 53. So when the number is ending with 7, again we need to find out the power is 4n plus 1, 4n plus 2, 4n plus 3 or 4n. So 53 divided by 4, you will get the remainder 1, right? 53 divided by 4, remainder is 1. That means it is 4n plus 1. 4n plus 1 means first power. So first power of 7 is 7 only. So whatever is this expanded value of these numbers, their unit place will be respectively 9, 4 and 7. 9, 4 and 7. Anything you want to ask? Okay. Okay, I hope we can continue, right? So here it will be 9 into 4 into 7. So the final product will be something like 9 into 4 into 7. So 9 into 4, here the unit place will be again 9 into 4, unit place will be 6, right? And 6 into 7, the unit place will be 2, right? We are just considering the unit place only because in the product, the unit place will be the product of the unit places. That is the basic things. So a number ending with a 9 is multiplied with another number ending with a 4. So the unit place of that product will be 9 into 4, 6. That is what we have written here. And again that number is multiplied with another number ending with 7. So the unit place will be 6 into 4. Final unit place will be 2 only. Okay. So now we can solve the problems one by one. You have to solve this problem. One minute. Try to do it yourself. Okay, how do we do it? See, this is a very tricky question. In 1 second you can reach to the answer. There is no need to take a pen and paper for this question. See, any number ending with 6, whatever is the power, unit place will be 6. Any number ending with 5, whatever is the power, unit place will be 5. And when we are multiplying a number ending with 6 with another number ending with 5, it will become 6 into 5. So the unit place of that product will be 0. So once 0 is in the unit place, whatever we are multiplying, final product will be ending in 0 only. Right? Unit place of the final product will be 0 only. So there is no need for doing it further. 6 into 5 unit place we got 0. Once 0 is there in the unit place, any product if you are further continuing, 0 into that number will become 0 only in the unit place. Okay, another question. A division is also coming here. 2 raised to 68 into 3 raised to 98 into 6 raised to 48 divided by 3 raised to 100 into 2 raised to 90. So first we have to apply the rule of exponent and we have to make it, we have to avoid this division part from there. So 2 raised to 68 into 3 raised to 98 into 6 raised to 48, we can write it something like 2 raised to 48 into 3 raised to 48, right? AB raised to m equals A raised to m into B raised to m. Divided by 3 raised to 100 into 2 raised to 90. So once we solve this one, we will get, for example, here it will be 98 and 100, minus 2 is here. Once we come here, that it will become 3 raised to 2. When it is coming to top, it will become minus 2, and finally the power of 3 will be 3 raised to 46, right? 3 raised to 46. And similarly, 2 raised to 68 into 2 raised to 48 divided by 2 raised to 90. So 68 plus 48, 60 plus 40, 100, 8 plus 8, 16. So it will be 2 raised to 116 minus 90. That means 2 raised to 26, right? 2 raised to 26. So final product will be something like this: 2 raised to 26 into 3 raised to 46, right? 2 raised to 26 into 3 raised to 46. The unit place of this one you can easily find it out, because a number ending with a 2, power value 26 means 4n plus 2, right? 4n plus 2 means 2 square 4, and here again 46 is also 4n plus 2, right? 4n plus 2 means 3 square. 3 square means 9. So 4 into 9, it will be 36. So unit place will be 6. The unit place of this expanded answer will be 6 only. Here I will explain once again. So once we solve these given exponents, we will get 2 raised to 26 into 3 raised to 46. 2 raised to 26. We know that when a number is ending with a 2, the power value is 4n plus 1, 4n plus 2, 4n plus 3, 4n. Based on that, we will come to the conclusion whatever is the unit place. So 26 means it is 4n plus 2, because when we divide 26, the remainder is 2. Remainder 2 means it is 4n plus 2. 4n plus 2 means second row. Second row means second power of 2. Second power of 2 is 4. Similarly, 3 raised to 46. We will divide 46 with 4. Remainder is 2. That means second row. Second row means second power of 3. Second power of 3 is 3 square, that is 9. So a number ending with 4 into a number ending with 9. It will be 4 into 9. The product is 36, and the unit place when we are taking it will be 6 only, right? So the unit place of this expanded answer will be 6. Clear? Okay. So some 2-3 examples also, then we can wind it up. Here 2 raised to 25. We will wind up our session by 4:40, right? So 15 minutes more there. By the time we can solve this. So find the digit in the unit place of 2 raised to 25. 25 factorial, sorry, 25 factorial. 25 factorial means, 25 factorial we know it is 1 into 2 into 3 into 4 into etc. up to 25, right? So when we are multiplying with 4, it automatically becomes a multiple of 4. So 25 factorial means it is a multiple of 4, because 25 factorial means 1 into 2 into 3 into 4 into etc. up to 25. 4 into means it becomes the multiple of 4. So we can say that this is 2 raised to 4n, 2 raised to 4n, 2 raised to 4n means fourth row, fourth row means fourth power of 2, that is 2 raised to 4. Fourth power of 2, we already know it is 6, right? 2 raised to 4 unit place is 6. So final answer will be 6 only. Instead of 25 factorial, even if it is 2 raised to 10 factorial, or if it is 2 raised to 100 factorial, if it is 2 raised to 30 factorial, if it is 2 raised to 5 factorial, then also answer will be same. Why? Because 4 factorial onwards, it will be the multiple of 4, right? 4 factorial means 1 into 2 into 3 into 4. That means it becomes a multiple of 4. Now for any higher value, it will automatically become the multiple of 4. So the final answer will be the fourth power of 2 when we are applying the rule. So 2 raised to 100 factorial, or 2 raised to 1000 factorial, or 10,000 factorial, whatever it comes, we are just finding whether it is a multiple of 4 or 4n plus 1, 4n plus 2 or 4n plus 3. So 4 factorial onwards it is a multiple of 4, that means it is 4n. So the fourth power of 2 will be taking, fourth power of 2 is 6. So the final answer of the unit place will be 6 only. Clear? Same type of question, 397 raised to 35 factorial. 397 raised to 35 factorial means when a number ending with 7, power value what we are taking care about? We will only take care whether it is a multiple of 4 or 4n plus 1, 4n plus 2, 4n plus 3 or for a multiple of 4, right? We know that 4 factorial onwards, whatever higher value it is coming, it's a multiple of 4 only. So this will be something like 397 raised to 4n. 397 raised to 4n means fourth power of 7. Fourth power of 7 means 7 raised to 4, right? 7 raised to 4 means 7 square into 7 square. 7 square ending with a 9. So 9 into 9, it will end with 1 only. So the unit place of this given term is 1 only. Unit place will be 1. Clear? Next one, 9 raised to 37 factorial. This is more easier question, because when it comes to 9, we will only consider whether it is odd or even, right? Whether the power is odd or even, because we know that 9 raised to odd power, unit place is 9, and 9 raised to even power, unit place will be 1. Unit place will be 1. So in this case, 37 factorial. So 37 is an odd number. 37 factorial is not an odd number, because except 0 factorial and 1 factorial, all the factorials are even only. From 2 factorial onwards, any number factorial, it is even only, because 3 factorial means 1 into 2 into 3. When this 2 into comes, it becomes even, right? So this is nothing but 9 raised to an even power 9 raised to even power means unit place is 1 only. So 9 raised to 37 factorial means unit place is 1. Instead of that, if it is 9 raised to 37, then unit place will be 9, because 9 raised to odd power, unit place will be 9. That's it. Another question. 5 raised to 5 factorial, 10 raised to 10 factorial, 15 raised to 15 factorial plus 20 raised to 20 factorial. Again, any number ending with 5, whatever is the power, unit place will be 5. Any number ending with 0, whatever is the power, unit place will be 0. Again 5, again 0. So you are adding a number ending with 5 with a number ending with 0. Again another number ending with 5, another number ending with 0. 5 plus 5, again it will become 10, where the unit place is 0. So the final answer will be 0 only. Another question. Okay, this is not directly related to the one which we have discussed, but again this is an elimination type question where we will apply the unit digit based on the unit digit based concept for elimination. So we need to find out from the given choices which among these given choices will completely divide, or 3 raised to 25 plus 3 raised to 26 plus 3 raised to 27 plus 3 raised to 28 is completely divisible by which among the following numbers. So here again it is not possible to find out the final value and then come to go through all these divisions and finally conclude which one is possible. We will eliminate using some short tricks. Just if you can see this, here we can take up the least value as common. Least value means 3 raised to 25, right? So 3 raised to 25 we can take as common one. If 3 raised to 25 is common value, within the bracket it will be something like 1 plus 3 plus, or 3 raised to 1 plus 3 square plus 3 cube, right? 3 raised to 25 into 1 plus 3 square plus 3 cube. This within the bracket values you can easily solve. 3 raised to 1 is 3, 3 square is 9 and 3 cube is 27. So when we add up all these things, what we will get? 3 raised to 25 into 27 plus 9, 36, 36 plus 3, 39 plus 1, 40, right? So this will something like 3 raised to 25 into 40, 3 raised to 25 into 40. Again, when we are comparing with the options given, it is not easily, eliminate, because if suppose one option was 10 here, we could have easily eliminated, because 40 is here. That means in this product anyway 1 0 is there. If 1 0 is there, that means it is a multiple of 10, right? So we can divide it with 10, but 10 is not given in this choice. So once again we will split this and we will make it something like 3 raised to 24 into 3 into 40. 3 raised to 24 into 3 into 40, because 3 raised to 24 into 3 means 3 raised to 25 only. Now if you go through this part, it will be 3 into 40, right? That means 3 raised to 24 into 120, you can say. Now you can come to the conclusion. We can divide it with 30, so the choice D is correct. Why? Because when we are multiplying 3 raised to 24 with 120, 120 is already a multiple of 30. So this product will easily get divided by 30 without any remainder or anything, completely divisible. So this way we can eliminate from the choices and we can come to the conclusion that this will be the answer. So 30 is the right answer. We can divide this expression completely with the 30. Okay. So rest of the part we will discuss tomorrow. So I'm just winding up this session, today's session here. One small part was there, but that we can discuss tomorrow. That won't take much time. That we will discuss tomorrow along with the other things which we will discuss tomorrow. So now some 10 to 15 minutes will be there for you to clear your doubts. If you have some doubts, you can ask me so that I will be able to clear the doubts. After that, there will be some questions based on today's class. That question you will get 20 minutes for solving. So that is also up there. But in that question, I think some 2-3 questions I didn't discuss the concept here. So you can avoid those questions if request. The rest of the questions you will be able to do. Okay. So I hope the coordinators were, you can unmute the participants' mic so that they will be able to ask the doubts.
Participants, please raise your hands for questions. We will unmute the hand raised persons.
No doubts. If there is no doubts, it means two things. Either you understood everything clearly, otherwise you didn't, understood anything. You didn't understand anything. So I hope if there is no doubts, then we can, start the question practice session, that competition. We can right now, we can start that.
Okay. Thank you, sir, for your session. It was very informative. Now,
Thank you.
okay, sir, thank you. Now, we send a form that will be available in the WhatsApp group in Teams and YouTube. You can use any of the form link to submit. The time duration is 20 minutes.
And tomorrow also we'll continue in the same time. We'll start from 2:30 and then we will finish rest of the topics tomorrow.
Please remember, we consider only the first response you submit. After submitting the form, you can leave team. And the tomorrow's session will begin at 2:30 p.m. All are requested to join on time.
Okay, so thank you all for participating in this program.